Today we're going to talk about graphing y equals ax squared plus c. So it's going to be super similar to what we did the other day, except for now we have this constant at the end that we're adding. So our learning goal, I will graph quadratic functions of the form y equals ax squared plus c and compare the graph to y equals ax squared, y equals x squared, our parent function, our parent parabola, and that is our goal for today. Now, if you think back, we've actually done something very similar to this before. Remember when we had something like the absolute value of x plus 3, and we had that plus 3 on the end? That was a vertical shift. So what this did is it just took our absolute value graph and it shifted it up 3 units. Turns out, when we're talking about quadratic functions, it's the exact same thing. So if we have just x squared plus c, if c is greater than 0, so if it's a positive number, the graph will shift up, or it's a vertical translation up c units. So if it's plus 2, we'll move up 2. If it's plus 8, we'll move up 8. If c is less than 0, so c is negative, it's a vertical translation, but it's going to go down c units. And that's the whole rule. So if you know what the graph is supposed to look like, you just need to shift it up or down. But again, when we're graphing our parabolas, we've just been making tables up until this point. So really, you can keep doing that. Yeah, you can just keep doing it with the table. So if we needed to graph this, x squared plus 6. I know that this graph is going to be a parabola. It's going to open up like this because my a is 1, so it's positive. So when I draw my axes, I'm going to make the top a lot bigger than the bottom because I know I'm going to need it to open up. I don't need it to be an equal 4 quadrants. So let's try -2, -1, 0, 1, 2 for my graph. If I put in -2, -2 squared is 4, plus 6 will be 10. -1 squared is 1, plus 6 is 7. 0 plus 6 is 6. 1 plus 6 is 7, and 2 squared is 4 plus 6 will give me 10 again. So let's see, 1, 2, 3, 4, 5, 8. I didn't even make this big enough. 9, 10. So when I put in -2, I get out 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. When I put in -1, I get out 1, 2, 3, 4, 5, 6, 7. When I put in 0, I get out 6. And then this is just the mirror image. So here is my graph of y equals x squared plus 6. And you can see if I graphed just y equals x squared, x squared would look like this. So it's the exact same shape. Same domain, I'm sorry, not same domain and range, exact same shape, it's just been shifted up. My original domain, let's do this in red, my original domain would be x is all real numbers, and my range would be that y is greater than or equal to 0, because y is 0 here, that's the minimum value, and then it opens up from there. If I look at the domain and range of my new graph, the domain is going to be the same. X is all real numbers. But then my range, the minimum of my graph here is at this vertex, which is at 0, 6. It's been shifted up 6 units. So my range is going to be that y is greater than or equal to 6 now, not 0. The whole thing got shifted. So I forgot to write range here. So that's just something to keep in mind. So for comparing these graphs, I would say they have the same shape, they open in the same direction, just my x squared plus 6 is shifted up 6 units, and that's how I would compare those graphs. Next, we're going to graph where we do have an a value. So a is not just 1. In this case, a is negative 1/3. So we're going to graph negative 1/3 x squared minus 1. In the back of my mind, I'm going to be thinking about what I know about this graph. It's going to be opening downwards because this is negative. It's going to be wider than my parent function, and it's going to be shifted. So I know it should look something like this compared to my parent function, which is just y equals x squared. So let's pick our values. Let's do something different. Let's do, how about negative 6, negative 3, 0, 3, and 6, and just see if that helps our numbers a little bit. So those are our x values. So negative 6 squared is 36. A third of 36 is 12, so that's going to be negative 12 minus 1 is negative 13. 3 squared is 9. A third of 9 is 3, and it's negative. So it'll be negative 3. 0, oh, I'm sorry. And then I'm subtracting one more, so negative 4. 0 minus 1 is negative 1. 3 squared is 9. 1/3 of 9 is 3, but it's negative, so negative 3 minus 1 is negative 4. I really should be showing my work for this. 6 squared is 36. 1/3 of 36 is 12, but it's negative 12 minus 1 is negative 13. So when I do this, 10, 11, 12. Oh my gosh, I'm so close. So negative 6, 1, 2, 3, 4, 5, 6. Negative 13 is way the heck down there. Negative 3, 1, 2, 3. Negative 4, 1, 2, 3, 4. 0, negative 1. And then 1, 2, 3. And 4, 5, 6 will be way down here. I know it's symmetric. So this is what my graph is going to look like. It's going to come all the way down and all the way down. So if I wanted to compare this to y equals x squared, I would say that it's a reflection over my x-axis, and I would say that it's shifted 1 unit down, and it's also wider. Because if we were to just graph the y equals x squared with the shift, or with the reflection in the shift, it would look like this. That's what negative x squared minus 1 would look like. So you can see that this graph is opening up wider than our original x squared graph. So again, we just made a table, but before I made that table, I thought about what my graph should look like, and just to make sure that I'm on the right track. Okay, our last example is a very common problem that you're going to see. You've already seen it a couple of times, and you're going to continue seeing it both in math and when you get into physics. So our function f of t equals negative 16t squared plus s sub 0 gives the approximate height in feet of a falling object t seconds after it's dropped from an initial height of s sub 0. So this represents how high the object is when you drop it. T represents how many seconds have gone by after dropping it. We want to know if an egg is dropped off a building that's 256 feet tall, when will the egg hit the ground? So this might seem like a weird thing to have in this chapter, but we can model this with a parabola, actually. So if we think about what our graph would look like. Negative 16 t squared plus s sub 0. In this case, our building is 256 feet tall. So our function is going to be negative 16 t squared plus 256. So if you think about a parabola, this is going to be a very narrow parabola. It's going to be upside down, but then it's going to be shifted up 256 units. So it's going to look something like this, where this up here is 256. So obviously I'm going to need to do some scaling on here. These cannot each be 1 foot, right? Also, if I think about what's happening then, this graph is showing me how high the object is off the ground if this is my time. So t seconds going by, at any one of these points, it's telling me the height of my object. If I want to know when the egg is hitting the ground, that would be when my height is 0. So when my parabola crosses this t-axis down here. What I am going to do is I'm going to pick a couple of values for t. Now I know that I can't have negative time, so that's why I don't really have a graph over here. I don't have room over there. Let's see. 10. Let's make each of these, oh, I don't even know. Let's do 75, 150, 225, 300, 375. Oh, I only need to go to 256. Let's do 50s then. So there's 250. So I'm starting 256 feet above the ground. What I'm going to do is let's pick some t-values. Let's pick 0, 2, and 4 and see if that helps me figure out when I'm going to hit the ground. So then I would put in 0 squared. So that's 0 plus 256. That makes sense. When no time has gone by, my object is 256 feet above the ground. Now I'm going to try f of 2. So negative 16 times 2 squared plus 256. So that's negative 16 times 4. Let's see, negative 16 times 4 is going to be negative 64 plus 256 will give me 192 feet. So if this is 2 seconds, it's going to be right about here. So not quite on the ground yet. Let's try 4 seconds. F of 4, negative 16 times 4 squared plus 256. So 16 times 16 is actually 256. So this is negative 256 plus 256, and I get 0. So f of 4 is 0. That means my graph is going to cross the t-axis after 4 seconds. And that tells me when my object hits the ground. So after 4 seconds, or at 4 seconds actually, is when my object hits the ground. Now if I had not picked 4, if I'd picked 3, then I still wouldn't quite be at the ground yet. I would be right around 100 feet. So then I would pick 4. You know, I would keep going. Or if I picked 5 and I got a negative number, I would know that, oh, somewhere between 2 and 5, my object has hit the ground. So then I would try 3, or I would try 4 until I got 0. So that's one way that you can do this. We will talk other ways where we can solve this a little bit easier, but for now we're using the graph to do it. So you're just going to have to pick a table of values and I guess in a way kind of get a little bit lucky. So that's what we're doing. Your homework. Homework is coming from page 420. And you're going to do 1 through 3, 8, 12, 19, 21, 22, 30 through 33, and 34 through 37. So make sure that you're answering the questions that it's asking, especially when it's asking you to compare to the parent function of y equals x squared. So get to it, and good luck.